What is snake venom?
Most venoms are mixtures of dozens of compounds. And the active toxic ingredients are proteins that wreak havoc on the recipient in a variety of ways. While the exact enzymes vary from species to species, and even geographically within a species. Many snake venoms contain some sort of neurotoxins which block signals sent through your nervous system, leading to numbness or even paralysis.
Can carbon chains form rings, too?
Yes, chains of carbon atoms can connect back to themselves, forming rings of atoms. The prefix cyclo is added to the name of the linear carbon chain to indicate that a ring is present, so hexane becomes cyclohexane. The chemistry ring structures can be different than their linear cousins because of the added energy that some rings contain. We know that sp3 hybridized atoms like to form bonds that are separated by 109.5 degrees. The more that a ring forces those bonds to deviate from that ideal angle, the more energy, called ring strain, that is released when that ring is opened during a chemical reaction.
What is a quantum?
A discrete amount of energy, electric charge, or another physical quantity.
What are MRI contrast agents and what are they used for in medicine?
Magnetic resonance imaging, MRI, see the modern chemical lab. Contrast agents are used to make tissues and other structures inside the body easier to view in an MRI scan. Many of these contrast agents are based on gadolinium with various ligands attached. The contrast agents are injected or ingested into the body, and they function by changing the relaxation time of the atoms observed in an MRI scan. The overall result is that these complexes improve the ability of MRI to see what is going on in your body.
How do molecules interact?
The forces molecules exert on each other fall into a few main categories. Van der Waals interactions. Van der Waals interactions are the broadest group of intermolecular interactions. This includes basically all attractive and repulsive forces that don't involve ions, charged atoms or molecules, or the rather unique situation of hydrogen bonding. Van der Waals interactions include forces due to the dipole moments of polar molecules, as well as interactions due to induced dipoles that can form even in nonpolar molecules. Ionic interactions. Another class of intermolecular attractions involves attractive and repulsive forces between pairs of ions, or between ions and neutrally charged atoms or molecules. These interactions are typically stronger than those in the van der Waals category. Interactions between pairs of ions are governed by Coulomb's law, while interactions between ions and neutral molecules are either ion dipole or ion-induced dipole interactions. Hydrogen bonding. A hydrogen bond is a strong interaction between a hydrogen atom and another electronegative atom. Usually fluorine, oxygen, or nitrogen, that are not covalently bonded to one another. The hydrogen atom also must typically be bonded to an electronegative atom, usually oxygen or nitrogen. The origin of this strong attractive interaction is that a hydrogen atom bonded to an electronegative atom has a partial positive charge due to its lack of electron density. This allows the hydrogen atom to have a strong attractive interaction with electronegative atoms, or ions, which have partial negative charges due to their extra electron density.
What is a significant figure?
A digit in a number that is known with some amount of accuracy.
Who ran the first chemistry experiment ever?
Jaber ibn Hayyan, known as Geber in Western texts, was probably the world's first alchemist to run actual experiments. Jaber lived during the 8th century in what is now Iran, and like alchemists before and after him, was fascinated by the prospect of changing one metal into another and by creating artificial life. To Aristotle's 4 elements, Jaber added sulfur and mercury, and proposed that all metals were made of differing ratios of these 2 elements. He was the first to emphasize the importance of rigorous experimentation, and is credited with describing many common lab techniques and equipment.
What are some applications of thin films?
Thin films are layers of material ranging in thickness from nanometers, 10 to 9 m, to micrometers, 10 to 6 m. They are used commonly for coating optical surfaces and also for coatings on semiconductors. Thin films are used to make mirrors, and these can be finely tuned. In terms of their composition and thickness, to obtain optical surfaces with a wide variety of specific reflection properties, such as wavelength-specific mirrors and two-way mirrors. The ones that are transparent from one side but reflective from the other. Thin films are also very useful for coating semiconductors to tune their conductive properties for different applications.
What is a phase diagram?
A plot that shows the phase in which a material is expected to exist as a function of variables like temperature and pressure.
How does NMR help chemists determine the structure of a compound?
The peaks in an NMR spectrum can be related to certain properties of a molecule's structure. The number of peaks present tells how many types of chemically distinct atoms of a given element are present.
What is adsorption?
Capture of one material onto the surface of another.
How can we make chemical reactions go faster?
Two of the most common ways to make a reaction proceed faster are to increase the temperature at which the reaction is carried out or to use a catalyst to lower the energetic barrier to the reaction. With increased temperature, the amount of thermal energy available to overcome the energetic barrier to the reaction is increased. Of course, you'll also get more products faster if you just increase the concentration, S, of the reactant, S. Light can also serve as the catalyst, breaking a chemical bond to produce a species that is more reactive than the original reactant species.
What is magnetic levitation?
Magnets apply forces on one another, and these forces can be either attractive or repulsive. If they are repulsive, and if the forces balance against the force of gravity in a carefully designed way, then the magnetic forces can be used to make an object levitate. This is put to practical use in high-speed trains, which can hover above the track while moving quickly on a magnetic cushion.